Dear student, next the topic of in the GOC, that is for the types of the organic reactions. Okay, so in generally the types of organic reaction, that is in the case of four types. Okay, so four types. The first one as a substitution reaction, substitution reaction, and the second one as that is for addition reaction. Okay, addition reaction, and the third category that is for elimination reaction, elimination reaction. Okay, and the fourth one for that is a rearrangement reaction. Okay, so these are four types of reaction. We can see that very elaborately. Okay, so first we go to that first type, that is for the substitution reaction. The substitution reaction can be replaced one atom or group. That is simply saying upcoming uh, group or atom, upcoming group or atom, such as either electrophile or nucleophile. Okay, the upcoming group or atoms can be exchanged, can be exchanged to another atom or group, another atom or else a group. Okay, this can be classified in two types. One is for electrophilic substitution reaction, electrophilic substitution reaction. Another one is for that is a nucleophilic substitution reaction. So this is a GOC unit. So it's a basically more general point of view we can study in this unit. Okay, so the electrophilic substitution is only for this kind. First case, there is a halogenation, halogenation of the electrophilic substitution reaction only for aromatic compound, aromatic compound. Okay, so there is a halogenation, and second category as nitration, and the third category for that is a sulfonation, and the fourth category as a Friedel-Crafts reaction, Friedel-Crafts reaction. This Friedel-Crafts reaction is two types. One is for alkylation, alkylation, and another one is a acylation. Okay, so that's all. The among these five types, actually there's a four types. This Friedel-Crafts reaction is classified two types. Entirely there's a five types. These five types mostly covered in that aromatic electrophilic substitution reaction. Okay, so that nucleophile, what are that nucleophilic substitution reaction? There is only for that types first category as a nucleophilic substitution reaction in the category of SN1, and there is a SN2, then there is a SNIA and SNAR. This they have given directly in the NCERT book, NCERT book. These two is a given, but there is a indirectly is given. Okay, indirectly is given. Okay, so anyway, these four types is very important in the nucleophilic substitution reaction. Cl in presence of OH minus. So now this OH minus can be replaced into that chlorine, or this chlorine can be replaced by the OH minus. So this is for that is a nucleophile. Okay, so this go to attack here, this Cl is removed. So what we can get, there's a CH3 OH plus Cl minus. So simply there is a one atom can be replaced by upcoming this group. So that is for that substitution reaction. This is for that is a SN2 type. This SN2 type we will study, there is a haloalkane and haloarine unit. Okay, haloalkane as well as a haloarine unit. This unit we will study, there is a future video. Okay, there is a simply the one atom or group can be replaced by upcoming atom or group. That is for that substitution reaction. Then next we go to that another types of reaction. There is a second category, that is for addition reaction. Okay, so this addition reaction, in the case of addition reaction, actually there is a from unsaturated compound, there is a unsaturated compound is converted to for saturated compound. Unsaturated is can be converted into saturated. Here the double bond and triple bond can be converted to carbon carbon single bond. Okay, so that mean unsaturated hydrocarbon is converted to saturated. Simply saying here there is a upcoming species, upcoming species, upcoming species or there's a atom or molecules, atom or group, atoms or groups that cannot be exchanged by other atom or group, cannot be exchanged into other atoms or groups. Okay, okay, so what did happen? This upcoming atom or group can be fixed in that parent molecule. For example, this can be classified in two types. One is for electrophilic aromatic substitute. This can be classified in two types. One is a electrophilic addition reaction. Another one is for there is a nucleophilic addition reaction. Okay, so these two type, what are the two types are presented like that? We will see here. Actually, the electrophilic addition reaction is occurred only for there is a alkene and there's a alkyne. Okay, this is the most example for that NEET and JEE related problems. And the alkane cannot be undergoes that is a electrophilic addition, or simply saying cannot undergo that alkane addition reaction, because alkanes each carbon is possessed of 4 sigma bond, that is cannot undergo that addition reaction. Okay, so because alkanes are saturated compound, that is cannot undergo that is a addition reaction. The nucleophilic addition reactions, there is a all carbonyl compounds, all carbonyl compounds, nitriles, etc. So these are the example of the nucleophilic addition reaction. For example, first one, there's a electrophilic addition reaction. There's a CH3, CH double bond CH2. We added that HCX. This HCX as a halo acid. The product as a CH3, CHX and CH3. Actually, this HCX, this separating by H plus and X minus. Okay, like that. This H plus as a behaves as a electrophile. This electrophile can be added to this pi bond. So whether this hydrogen added to this hydrogen or this hydrogen is depend upon that the formation of carbocation. We will study for a future alkene unit. Actually, that is hydrocarbon unit. That is very elaborately. Okay, whether the compound as a major or minor depends on that. Simply, I am given that is a electrophilic addition reaction, one of the example. And nucleophilic addition reaction example. See, there is a RC double bond OH. This for aldehyde. This react with HCN. So this nucleophile species, this is electrophile species. This go to attack first, and this bond separated here. What we can get ROH and H here as a CN, as a cyanohydrin as a product. Okay, anyway, the unsaturated, or simply saying double bond can be attacked initially by electrophile, that is for electrophilic addition reaction, or there is a nucleophile that can be nucleophilic addition reaction. Okay, so all carbonyl compounds in presence of base or a nucleophile, that is undergoes the nucleophilic addition reactions. Okay. Okay, next we go to for there is a third type, such as there is a elimination reaction. Okay, this elimination reactions actually the already containing group can be eliminated. We can get in the unsaturated compound. Okay, so there is a already containing groups or atoms can be eliminated. Okay, can be eliminated at the result of we can get unsaturated compound. Okay, unsaturated compound. Okay, so this unsaturated compound, whether there is a alkene or alkyne. Okay, those among these two is anyone that is most probably given in that elimination product. This elimination can be separated by there is various types. For example, first case as a E1 elimination, and the second type as a E2 elimination, and the third type as a E1CB elimination, and there is a fourth type as a alpha elimination, and there is a fifth type as a beta elimination, and there is a beta elimination and sin elimination, and there is this anti elimination. Okay, so like that the elimination reactions can be classified in the various type. This is also there is a we will study, there is a future video. In generally, the elimination reaction are directly proportional of beta hydrogen. Okay, so this is very important. This elimination also it's classified another way. There is a Saintsev elimination as well as there is a Hoffman elimination. Okay, this also is very important. Actually, these all are there is studied in the previous classes or future upcoming video. We will study in this all are the eliminations. Okay, the next kind of types of reaction, such as there is a rearrangement reaction. Okay, there is a fourth type as a rearrangement reaction. This rearrangement actually simply that depends upon that molecular stability they have rearranged. For example, see the CH3 CH plus and there is a CH3. Okay, this for that is secondary carbocation. This more stable compared to that primary carbocation CH2 plus. So both it has the same molecular formula, but it's a secondary, it's for that primary. Okay, the stability order based on that the molecules are rearranged. For example, the CH3 CH and CH3 CH2 as a plus here. So this is for the primary carbocation. In comparatively primary, secondary, tertiary, such tertiary carbocation are more stable. This already studied in the previous video. So this primary will become to the most stable. For example, the CH3, CH3, CH3 here is a plus. So this carbocation is a tertiary carbocation. Actually, that hydrogen, this hydrogen can be shifted to this position. That is nothing but 1,2 hydrogen shift, 1,2 H shift. Okay, so based on that, we can get the primary into the tertiary carbocation. Okay, so whatever that, similar like lot of the molecules can be rearranged based on that the stability aspect. Okay, so in the higher education, the Claisen rearrangement, cope rearrangement, axe cope rearrangement, so like that, etc., etc., a lot of there, but that's not covered in that the NEET and JEE related problem. But the rearrangement of carbocation, that is covered in that NEET and JEE problems. Okay, that's why I'm saying here. So this much is enough for that rearrangement reactions. Okay, we will detail explanation for upcoming videos, especially in the carbocation or the hydrocarbon and the halogen halorine. For that topic is covered in that kind of reactions. Okay, if you like in this video, you can subscribe and share with friends.
Amazing!
Thank you to all very much. Thank you.